We're on the last lesson of Unit 2. We're moving right along in Algebra 1. We're going to introduce you to something today called interval notation. As you can see below, we have a number line. And now we've learned that an open hole on a number line does not include a number, and a closed circle includes the number. And like I said, we use these with number lines. But we're going to learn a new and better way to represent this. Because basically, all right, let me just go down to here. This is a conjunction, right? We should know that by now. And the lowest form of representing this would be to use a number line. So I would come over here, and -3, we know by now, would get the dark circle. 9 would get the open circle. And then we would shade everything in between because it is a conjunction. It's saying I can choose any number from -3 up to 9. Now, this and this, they're the same thing. It's like saying hi or hello. You know, we have formal and informal ways of greeting each other. So this, the graph, is shockingly called a graphical representation. What do you think this is called? Algebraic. And then we have something that we use in upper level math called interval notation, because it's the quickest way to write it. If I were to write this example in interval notation, it would be this. All right, let's compare and contrast. We've just learned a new symbol. Hopefully you picked it up when I wrote it down. That's right, when we do interval notation, include, we use a bracket, a square bracket. For does not include, we use an open parenthesis. So this is the way we would like you to start expressing your answers. It's upper level, because you can see it takes very quickly to write it, and it conveys the same message. I can choose -3 all the way up to, but not including, 9. So let's practice some examples. Here we have the algebraic. If I were to ask you to represent that graphically, you'd say no problem. -6, 4. This is a conjunction, so I will conjoin my two numbers. But if you were in calculus, you'd write it as such. Since there are two open circles, because we cannot pick our boundaries, we use parentheses. And then we tell ourselves that it runs from -6 to 4, what we would say exclusively. Now some of you may say, wait, that looks like a point. But if we were answering the question, it pertains back to the question, so we couldn't confuse that with a point. How about this one? Example 2. X is greater than or equal to 4. Well, this is not a conjunction. It's not a disjunction. So, all right, let me graph it because that's not hard. I go to 4. I circle it. I can include 4 because there's an equal sign. And now it says everything greater than 4. So I shade that way. All right, well, how do I represent that in interval notation? Well, I can include 4, so I do a square bracket. And then I use the infinity sign. And the infinity sign gets an open bracket because nobody knows what the last number in the world is. There is none. Because as soon as you say Gaboo Gaboo Gabaga is the biggest number in the world, all I have to do is say, no, Gaboo Gaboo Gabaga plus 1 more. So there is no biggest number in the world. How about example 3? Okay, x is less than 4. Go to 4. And I can shade less than it. It's an or statement. So my graph is going to be going this way or that way. What's the other way it goes? X is greater than or equal to 9. So that gets shaded in and shaded that way. All right, so for interval notation, I actually have 2 intervals that I have to graph. So I have to show them this way. This graph goes all the way down to negative infinity and up to, but not including 4. This part of the graph starts at 9 and goes on to infinity. Make that look square, it looks round. And then of course I have to put an or sign, and I can use the word, or let's be real professional. Do you remember the symbol for or? That's right, it's a V. So there's the interval notation for this algebra or graph. X does not equal 5 is example 4. Well, that means I can pick any x I want except 5. Okay, so I can't pick 5, so I'm going to put a nice open circle on it. Move it. But now I can pick any other number. Well, it means I can pick any number above it. Or I can pick any number below it. Now, how am I going to represent that in interval notation? Well, there's 2 ways. A long way and a short way. Well, I could do this. I could say, okay, I'm going all the way down to infinity, negative. I'm going all the way up to 5, but I'm not including it, so it gets an open parentheses. Or I'm going all the way above 5. And there's even one more short way to write it. I could do this. I could use that all, whoops, that doesn't look good. I could say every number in the world works except 5. So now you've learned a lot of things today. We'll review what you learned. You learned that closed brackets mean to include. You learned rounded brackets mean to exclude. This is really a review. That means all reals. And now this slash sign means except. So all of these 4 representations mean the same thing. It's kind of like saying 6, half of 12, a quarter of 24, a fifth of 30. They all mean 6. Get it? All right, I'm going to clean this page up. We'll get to our last problem. hydroelectric plant, at a hydroelectric plant, pump 1 is on for all times on the interval from 0 to 8. I don't know if that means hours. I don't know what that means, but here's that interval notation. Down here I have some graphs. Wonder what I'm going to use them for. I have interval notation here. Why do I need graphs? Well, I'm going to keep reading. Pump 2 is on for all times in the interval 4 to 18, inclusive of 4, exclusive of 18. Which of the following represents all t times when the pumps are on? Well, sorry, I copied this problem from somewhere else, and it obviously was a multiple choice, but I want us to figure it out without multiple choice. So I'm going to graph these for help. First thing I'm going to look at is this 0 right here. It's inclusive. So I get to put a dot over the 0 and fill it in. It goes all the way up to 8. But 8 does not get filled in. Since it's on all in between this interval, this all gets shaded in. All right, next one. Four gets an inclusive dot. 18 gets an exclusive dot. And once again, I get to shade in between because it's on that interval. Okay, now, when are the pumps both on? Well, I want to do something here first to give you a better visual. I'm going to hook those all together, and then I'm going to change the color on them. And then I'm going to move it up here so they're almost on top of each other, and they're asking me, where are they together? Now I need a line to help me with this. Well, it seems to be that right here they're both on, and kind of right there. Because over here, only blue is on, and over here, only red is on. It's in between where they are both on. All right, so this number right here is 4, and since it's shaded in both, it gets a square bracket. And then up to here, this is 8, but this guy is on in 8, and this guy isn't, so 8 must get an open bracket. So these pumps are both on from 4 to 8. Who knows? Maybe they're using military time here. We don't know what 4 and 8 represent, but we did answer the question. All right, we got some tricky ones to do tomorrow, and I'll see you then.